What is calculus anyway?
Yeah, that's what I'd like to know.
Calculus is the study of how things change.
Boom, pow.
Calculus is applicable in many other subjects such as physics, chemistry, and economics. Calculus allows us to express many physical laws mathematically. It allows us to further analyze these laws and predict the behavior of the things governed by them.
Pierre de Fermat was born in Beaumont de Lomagne, France in August of 1601 and died in 1665. He is considered to be one of the greatest mathematicians of the 17th century. Fermat's father was a leather merchant as his mother's family was in the legal profession. Fermat attended a Franciscan monastery before moving on to obtain a bachelor's degree in civil law from the University of Orleans in 1631. He married, had 5 children, and practiced law. For the most part, math was a hobby of Fermat. Fermat was a busy lawyer and did not let his love of math completely take over his time. It's been said that Fermat never wanted anything to be published as he considered math to be a hobby. The one thing he did publish, he did so anonymously. He sent many of his papers by mail to some of the best mathematicians in France. It was his link with Marin Mersenne that gave Fermat his international reputation. Fermat loved to dabble in math and rarely provided his proofs. He would state theorems but neglected the proofs. In fact, his most famous work, Fermat's last theorem, remained without a proof until 1993 when Andrew J. Wiles provided the first proof. During Fermat's lifetime, he received very low recognition as a mathematician. If not for the fact that others saved his papers and letters, he may not be the legacy that he is seen as today. Fermat's most important contribution to calculus is the Fermat's theorem, which is a method to find local maxima and minima of functions by showing that every local extremum of the function is a stationary point, or where f prime of x equals 0.
Newton's law of cooling is used to model the temperature of change of an object of some temperature placed in an environment of a different temperature. Some applications of Newton's law of cooling are to predict how long it takes for a hot object to cool down at a certain temperature, to find the temperature of a soda placed in a refrigerator by a certain amount of time, and it helps indicate the time of death given the probable body temperature at the time of death and current body temperature. Newton's law of cooling states that the rate of temperature of the body is proportional to the difference between the temperature of the body and that of the surroundings. This leads to the equation of exponential decline over time, which can be applied to many areas in science and engineering, including the discharge of a capacitor and the decay in radioactivity. Newton's law of cooling is useful for studying water heating because it can tell how fast the hot water in pipes cools off. A practical application is that it can tell how fast a water heater cools down if you turn off the breaker, say if you go on vacation.
Gottfried Wilhelm Leibniz was a prominent German mathematician and philosopher. Born on July 1st, 1646, in Leipzig, he was raised predominantly by his mother, as his father passed away when he was only 6 years old. Despite this, his deceased father still had a significant impact on Leibniz's life. A professor of moral philosophy at the University of Leipzig, his father had a personal library which he left behind for his son after his passing. The library contained a wide variety of advanced material, which his son would have otherwise not had access to until his college years. Leibniz completed his bachelor's degree at age 16. 2 years later, the young man earned his master's degree in philosophy. Leibniz did not begin working on calculus until 1674. It was just a year later that he made a critical breakthrough, when he employed integral calculus for the first time to find the area under the graph of a function. His breakthrough led to the development of his own notation, which uses the symbols dx and dy. In addition to his other breakthroughs, he also developed the product rule used for differentiation. Also, the theorem that tells how and when to differentiate under the integral sign is called the Leibniz integral rule. He published an account on differential calculus in 1684, and then published the explanation of integral calculus in 1686. However, this led to a great deal of controversy. Isaac Newton, who also had findings regarding calculus, published an article outlining his discoveries in 1687. The fact that Leibniz published findings on calculus first meant he received total credit for the discovery for a number of years. This, of course, led to a number of accusations of plagiarism. After lengthy investigations, the Royal Society concluded that Sir Isaac Newton had truly discovered calculus, and that Leibniz was guilty of plagiarism. Tragically, Leibniz died before it became known that these accusations were in fact false, and both men were then given credit for the discovery.
DJ Khaled,